Hello everyone, in this video we'll learn about the type of chemical bonds. So let's start with unit 5, chemical bonding. So first of all, let's see why do elements bond together. What's the need of making a chemical bond? So this is because they need to lower the potential energy, right? So bonds are formed because the element in the bonded state have lowest potential energy. So atoms that are bonded together have less potential energy compared to the potential energy of the separate atoms. For example, if we have two hydrogen atoms, so this is hydrogen atom 1 and this is hydrogen atom 2, right? So these two have high potential energy when they are separate, right? But when they bond together, their electron clouds overlap. So this is kind of their overlapped clouds, right? So then they have low potential energy. So this is the bond, chemical bond formed between two hydrogen atoms. So individual atoms have high potential energy, and bonded atoms, when they bond together, they have low potential energy. So that is why the elements bond together, right? Because low energy means more stable state. So here is our potential energy diagram. Look, so we have plotted the potential energy on the y-axis and the distance between the two hydrogen atoms on the x-axis, right? So now look, this is how it goes. So when we have two individual atoms, they have quite high potential energy. So let's say this is the value of unbonded atoms, right? So this value right here is the energy of the two hydrogen atoms, right? This is the value because both the atoms are identical, they have the same potential energy. So let's say this is the energy. Now as you decrease the distance, so now on the x-axis we have the distance between the two atoms. Now as you are decreasing the distance, the potential energy is also decreasing. As the atoms are coming closer and closer together, look, the distance between the two atoms is decreasing. The atoms are getting closer and closer. Now when a particular distance is reached between the two atoms, so at this point, this is the lowest energy in this curve, right? So when the two hydrogen atoms come to a particular distance close enough to each other, there is a value of potential energy that is lowest. So this energy value that I have written as E star B, this is the bond energy, the lowest potential energy, right? And then the distance between the atoms when they have this lowest energy is what we call bond length. BL refers to the bond length, the bonded distance. So this is the bond length, right? Now if I keep on pushing the atoms closer than this bond length, right, when they become closer and closer, you can see the potential energy starts to increase. So now these two atoms are very close to each other. Now what happens when the atoms come too close than the bonding distance? The repulsions between protons increase. Repulsions between protons increase as the atoms come too close, even closer than the bonded distance, right? So this is the highest potential energy. You can see this is the highest potential energy because there are so many repulsions. The two nuclei being positively charged are going to repel each other. So the repulsions increase, that makes the atoms unstable, and hence the potential energy increases. Right? So we have to be just right distance when we call the two atoms are bonded, and this is called the bond length. The distance, the ideal distance where the potential energy between the two hydrogen atoms is the lowest, is what we call the bonded distance or the bond length. Now let's talk about the ionic bonds, the types of bonds. The first bond that we are going to discuss is the ionic bond. Always remember, ionic bonds are formed between a metal atom and a non-metal atom. So one atom has to be a metal and the other atom has to be a non-metal, and you know where the metals are found, right? So we have this staircase. All these ones that I have highlighted in blue, they are the metalloids, and the yellow ones are the non-metals. And on to the left hand side of that staircase we have the metals. So metals are S, D, and some elements of the P block like lead and tin, these are also metals, right? So all the S, D block transition metals and some in the P block are called metals. Okay? Now the non-metals are the ones to the right of the staircase, and the elements along the staircase are called metalloids or semi-metals. So all these ones are non-metals. So one atom should be from the non-metals and one atom should be from the metals, only then the ionic compound will be formed. So what is an ionic bond? Ionic bond is nothing but electrostatic attraction between a cation and an anion. Remember, the opposite charges attract each other, right? So there is a force of attraction between the positively charged cation and a negatively charged anion. This force of attraction is what we refer to as an ionic bond. So it is the electrostatic attraction between a cation and anion. Now let's recall how cations and anions are formed. So let's do an example of NaCl. Now sodium has 11 protons or atomic number of 11, right? It has configuration of 1s2, 2s2, 2p6, 3s1. So it has one valence electron. Sodium has one valence electron. So I can write sodium, symbol of sodium, and then show one valence electron. Always remember, it's always the valence electrons that participate in a bond formation. No other electrons participate, only the valence electrons. So when we are representing or making a bond, we always will show the valence electrons. Since sodium has only one valence electron, I put a dot next to the symbol of sodium, showing that it has one valence electron. And the orbital diagram or the Bohr model would be something like that. It has three energy levels, 1s2 and 2, n equals 2 and n equals 3, right? And the third energy level is the valence shell that has one valence electron. So this is the electron that we are talking about here. Now let's draw chlorine. Chlorine has atomic number 17 and this is the configuration. N equals 3 is the valence shell, and the n equals 3, the third valence shell has 7 valence electrons. So I wrote the element symbol chlorine and put 7 dots around it, showing only the valence electrons of chlorine. So it has 7 valence electrons. And if I draw the Bohr model, so 2, 4, 5, 6 and 7. So 7 electrons in n equals 3, 7 valence electrons. Now sodium loses one electron. You take away one electron from sodium and it makes sodium 1+. So this electron right here, the valence electron is lost by sodium. But the electrons do not just disappear in thin air, right? So if an atom is losing electron, there should be another atom that would gain that electron, because electrons cannot just vanish, right? There has to be a give and take. If someone is giving, there should be someone that is taking that electron, right? So sodium, when loses one electron, it will have a noble gas configuration of neon. So sodium ion is going to be 1s2, 2s2, 2p6, which is just like neon, right? So sodium is happy when it loses one electron, and chlorine can gain 3s2, 3p6 configuration, which is just like argon when it gains one electron. Remember, chlorine, the halogens group 17, they gain one electron to look like noble gases. So this electron right here is gained by chlorine. Now this electron that sodium donated is now a part of chlorine, and then this becomes chloride ion. So this is chloride ion. So we can draw it here. Sodium lost one valence electron and it has a positive charge now. The chlorine gained the electron donated by sodium and it becomes a negatively charged ion. Since it has so many valence electrons, we can put them in square brackets and put the charge on the chlorine atom, right? Now we have a negative ion, the chloride ion, and we have a sodium ion, which is a cation, right? So ionic bond is formed between a cation and an anion, right? It's the force of attraction between the positively charged ion and a negatively charged ion. This force of attraction is what we refer to. So this is the force of attraction, what we call an ionic bond, right? So this is the ionic bond formed between sodium and chloride, and this is how we represent an ionic bond, right? So cations with a positive charge, anion with all the valence electrons donated by the cation, and with a negative charge. Okay. So let's look at the other type of the bond that we need to know. Next type of bond that we want to know is a covalent bond, right? So what is a covalent bond? Covalent bond is formed by sharing of electrons. Remember, in ionic bond there is a give and take. One atom gives electrons, the other one takes it. But here nobody is willing to get rid of or lose their electrons, and nobody is willing to gain electrons, right? There's no metal that is going to be there to lose an electron. So what happens? How are covalent bonds formed? These are formed when we have two elements that are both non-metals. Always remember, non-metals like to gain electrons and form negative ions, right? And it's the metal that always loses electrons. But here nobody is willing to lose any electrons. They both are non-metals, right? So what do? They, instead of losing or gaining electrons, they like to share electrons in order to look like noble gases. Share electrons to look like noble gases. Right? So examples are CH4, Cl2, H2O, ammonia, and so on. Now look, carbon is a non-metal and so is hydrogen. They both are non-metals. Okay. This is the bond formed between two chlorine atoms, chlorine and another chlorine. They both are again non-metals. Hydrogen and oxygen, they both are non-metals. Hydrogen and oxygen, right? So this is the bond we are talking about. They are both non-metals, both the elements are non-metals, and hence it is a covalent bond. Ammonia, nitrogen and hydrogen, they both are non-metals. They are on the right side of the staircase, right? So the bond formed between nitrogen and hydrogen will always be a covalent bond. Okay. Now let's look at an example. Let's do this example right here. So carbon has 6 electrons, right? So the configuration is 1s2, 2s2, 2p2, and carbon has 4 valence electrons, right? So in order to look like neon, it needs 4 more. Now there's no one to give 4 electrons to carbon, because carbon is, say, surrounded by hydrogen only, right? So hydrogen has 1 valence electron and it needs 1 more to look like helium. So hydrogen wants to look like helium by having 1 more valence electron, and carbon can look like neon if it has 4 more valence electrons. So what happens? Since carbon needs 4 more to complete its 8 or octet, we call it octet, having 8 electrons in their valence shell, and hydrogen needs 1 more to have 2 in the valence shell, right, and look like helium. So now look, carbon and hydrogen are both non-metals, right? So neither of them is going to lose any electrons. They both they want electrons, but they cannot lose electrons to look like noble gases. So what's the option? They would share electrons. They do not lose or gain electrons, rather they believe in sharing, right? So how do they share electrons? Now this is carbon. Carbon has 2 electrons in n equals 1 and 4 electrons in n equals 2. 1, 2, 3, 4. And carbon needs 4 more to get 8 and look like neon, right? So what happens? Now look what I'm gonna do. So this is hydrogen. So hydrogen has only 1 electron. So this electron, 1 hydrogen atom can share its electron with the carbon, right? So carbon now has 1, 2, 3, 4, 5 electrons, right? It's still short of 3. So another hydrogen can share its only electron with the carbon, right? Now carbon needs 2 more, right? So another hydrogen atom comes in and shares its electron. I'm doing blue for hydrogen, red electrons are for carbon, and then a 4th electron from the other hydrogen atom. Look, each hydrogen has now 2 and it looks like helium now, right? And carbon has 1, 2, 3, 4, 5, 6, 7, 8 valence electrons, right? So each shared pair, the red and the blue pair, is what we refer to a covalent bond. So this is the shared pair, shared between hydrogen and carbon, right? So this shared pair of electrons is what we know as a covalent bond. And then how do we draw a covalent bond? So we put carbon in center because carbon has most electron and is sharing it with the hydrogens, right? And so this bond, this bond, this bond, this bond, this is a covalent bond, right? So carbon, in other words, we can say carbon makes 4 single bonds with hydrogen, single covalent bonds, right? Which is always a shared pair of electrons. right? So this shared pair is kind of written like a dash. Okay? So covalent bond is formed by sharing of electrons always. The last type of bond that we are going to discuss is metallic bonds. Now all those metal atoms out there, metals, when they are not bonding, they are just by themselves because they are pretty stable, right? Iron metal, look at iron metal, copper metal, gold, silver, all these metals, when they are not bonding with a non-metal, right, they have metallic bonds in them. This is how metals exist in nature, right? So metal atoms, what happens now, since metal like to lose electrons, what happens, the electrons detach from the metal atoms and they form cations, right? So how does the metal look like when we have a pure metal? Metals, they kind of are sea of mobile electrons, right, that have cations embedded in it, right? It's kind of like a sea of electrons that surrounds the cations of the metal. Each metal atom, so if this was the metal atom, this metal atom loses one electron and forms a cation, right? So this is what it looks like. All the metal atoms do the same. They just get rid of their electrons, the valence electrons, lose one or two, and they turn into cations. So it's kind of a sea of mobile electrons that surrounds the metal cations, right? And these mobile electrons can flow when we apply a charge on a metal, right? So this is what we call a metallic bond, right? So this is how a metallic bond looks like. So you can see the freely flowing electrons that can align and move when we apply charge, right? And then we have these metal cations, right? So it's a kind of a mix, right? This is what we know as metallic bonds, right? So these are all the three types of bonds that we need to know for this lesson. That's all. Thank you.